And this is part, is it set B or set A?
Yeah.
Set B or set A? Is it set B?
Yeah, it's the first one.
First one, okay. The one about the months of the year?
Yeah.
Okay. So this one's got J is January, June, July. S is June, July, August. W is December, January, February. List the members of each of the following. So you had trouble with part D?
Yeah, I guess the reason why I was having difficulty, I was like checking my answers in the back of the book. But for 25E, they included months that weren't included in the list, so I think that's what was funny.
Oh. M is the month, all the months in the year.
Oh, okay.
So when they do M minus, then it's all the months of the year that aren't represented by those. Yeah.
Oh, okay.
Does it make sense? So each of the ones they gave us are some of the months. M is all the months.
Okay.
So when they say M minus, you're going to see months that you don't see listed because that's in the bigger set of all months.
Okay.
Yeah. I lock it. All right. Anything else? Yes.
Number 18 on set B. Really all of them, but I guess C was the most confusing.
Oh, draw Venn diagrams, that one?
Yeah.
So, all right, let's see. So, all right, how do I want to say this? So this one says, they give you, for example, can you draw a Venn diagram where, actually, let me give you one they don't give you. Can you draw a Venn diagram where this is true? So draw a set A and a set B so that the intersection of A with B is B. Think about that for how the hell. So we're used to, so it obviously can't be this like standard picture, correct? The intersection of A and B is not equal to B. Yes? But think, so why is the intersection here not equal to the entire set B? Why is that answer? And I know this isn't directly your question, but I'm kind of building. Why is the answer to this question here not equal to set B? It's almost a silly question, right? But just articulate it for me. Why is the intersection not the whole set B? You could do it, you could do it.
Because it shares it with A.
Say again?
Because it's sharing it with A, so it's...
Yeah, it's only the part that B shares with A, sure. So how would you change the picture? And you could put the circles wherever the hell you want to in there. This is just one way to do it, right? What would you change about something in here so that the intersection is the whole set B?
So it's separate?
No.
Right on top of each other?
Yeah, okay. So one way to do it is to have A, this is A, right? Let me come in with a different color. And then this is B. Oh, shit. Okay. So this is B. All right, let me not put it there, let me put it there. What's A intersect B? What do A and B have in common? Is really the question. Don't A and B have B in common, right? Now, couldn't the answer also be A, though, technically?
Yeah.
Right? Because in this case, A equals B. All right? Are you guys okay? So the way I was thinking would have been, right? Okay, so that's kind of like the idea behind this problem and the parts of it. The one you're looking at is really strange. Did everybody kind of get this today? I did. So you start with what you know, and you ask yourself, well, why is this intersection not that? And that kind of leads you to, what do I need to change about this to make it match what they say? Right? So, the one you're looking at, let me see if I can talk a little bit about it without just giving the answer away. The one you're looking at says they want A intersect B minus B to be that. What does that mean again? Empty set. So they want the result of this to be nothing. I accidentally just gave away the game, but, yeah, that's all I'll say then. So they want you to draw a picture. So you have set A as a circle, set B as a circle. They could touch, they could not touch. One could be in the other one, right? And they want, if you do this with the picture you draw, you end up with nothing left. So A intersect B minus set B is nothing. They want nothing left when you do that. And if you think about it, my example was way too nice. I didn't even mean to do that. I kind of gave it away, but that's all right. If you don't quite get what I'm saying, then just say, I don't quite get this one. Right? That's fine. Okay. Anything else? Yes.
That's for set B, 18.
Yeah, set B 18, 2-1.
Number C.
Yeah, it's really weird. It's going to be interesting this semester. We're going to be referring to legal documents, sort of like subsection, paragraph this, right? I'm sorry, you got set A, set B. I know. All right. Okay, let me say this because it's sort of like weighing me down a little bit. So everybody look at me, this Thursday, it's not a good reason, so don't celebrate too much, but we're not going to have class Thursday. Because a friend of mine passed away last Thursday. So just, really old friend from high school. I knew him longer than some of you guys have been alive, just to put that out there, right, y'all? I knew you were old, but shit. Anyway, I didn't need to tell you everything, but I just wanted to let you know because I know I'm probably acting a little weirder than normal, and you guys don't even know me. So I'm like, I gotta let them know some stuff. So this Thursday, just no class, right? It's fine. I don't think we'll change things if we need to. I think we're actually a little ahead right now, sort of. So we'll see if it has to change anything further down the road. Yeah, okay. You can email me. You can do stuff if you need to. I'll still be checking every now and again. All right, now let's see if I can let that go for a bit. Any other questions from homework stuff or?
I'm assuming you already did A and B for that one. Set 8.
No. The question was all about C.
That was only C. Okay.
Yeah.
I had some about the last one. Well, actually, number 24 of set B.
Okay.
D and F, and I guess G too.
All right.
Those I was gonna. Well, D and F. Yeah, I comprehended it, but I didn't know how to put it down, and then G.
All right.
Yeah.
Throw it up here real quick. Let's see. So 24. Just make sure we're looking at the same one. That's the one that gives you R is ABC.
Mm-hmm.
Okay.
$27 also too, because it has the complement bar, but over the whole operation.
Oh yeah.
So that was the one that I was gonna.
No problem. Oh, cool. All right. Let's see if I can make this work. All right, here's 24. So they give you 3 sets. What does this symbol here mean, of course? Or. And so the way to think about or really is the answer will have all the elements that are in one set or the other. That's why it's always bigger, if anything.
Yeah.
So the way I always do this is I kind of take the first set and they're part of the answer. And then I just throw in. So your question, I just want to kind of get us in the right mindset.
So my question, as far as how to write it out, would be for D and F, because they don't have any elements that are in the same set.
Well, I love it. Yeah, so what do you put?
So it's just blank?
You could either put the set brackets blank,
Okay,
or you could put that 0
Empty
with the
set.
line. They
Okay.
both mean empty set, yeah.
got it. And
Shit,
then
yes.
I guess my real question would be then about G.
G is funny.
Yeah.
Okay, so one other way to look at this, because it's also an OR, right?
Yeah.
It would be everything in OR, and you add to it everything in S that's not in R, right? So it's everything in R, and you would add to it everything that's in S that's not in R. Does that make sense?
Okay.
So OR is kind of like an additive thing. It adds more stuff, right? So what am I adding to the set T?
And the empty set.
So does T change? No, good. So T or empty set is like 5 plus 0.
Okay.
Same kind of idea, right? I'm not adding anything to T. Who's coming? Well, it's either these guys or the people that are in that empty room over there. It's like, just say these guys. What the shit, right?
So
Maybe.
it just makes it just T then.
Yep.
Okay.
Just to give one away. What would it be if it was intersect?
Nothing.
Yeah, exactly. Who's in this room? And in that empty room over there. It's like, what the hell?
Yeah.
Okay, I like it.
Yeah, there were some that even from set A that I was kind of like,
Yes,
I
some
guess
of
we
the
saw it in
homework
class.
does push you further,
Yeah.
in which I really like. So the main thing with homework is obviously ask questions if you hit some that don't make sense. If there's just a few of them that you're not sure, it's okay to kind of leave them blank or put a little question mark or something. And if I have time when I'm grading stuff, I can kind of put little notes or something because you're gonna make corrections anyway. But yeah, the main thing is ask questions. Yeah, so some of them get pretty weird sometimes, and I love that. I would.
did someone else have like issues with that, or was I the only one?
There's other people that are like, oh good, I haven't gotten there yet, but now I have some idea.
But 27 also.
Yeah, 27.
If that would be fine, because it took that one stumped me. I was like, oh shit.
27, where are you? Oh yeah. There we go. There. Yeah, so that bar here, what does it mean?
So it's the complement.
Complement. Which really means what? Can somebody give me an idea to think of that bar using words we know better? Like complement is kind of new to us. So like this bar, this thing right here. A is the set with all the stuff in it that A has in it. What is the bar over the A? What set would that mean?
Everything was not there.
Yeah, everything that's not an A that's in the universe, right? So that's kind of like that little bar really does mean not. So it's a set of elements that are not in A. I like it. So what does this mean? Well, cover the bar up. What's under the bar? A intersect B. So this is everything that's not in A and B.
Okay.
So whatever that bar is over, whatever that set represents, the bar makes it the opposite of that, right?
Yeah.
So since that bar is over the whole thing, think of that set by itself and the opposite of that. I like it.
Okay.
Does that help with
Very
the
good.
trying this thing out?
Yeah, definitely. And then, so it's pretty much, because there was another problem, but I think it was in set A, that was like, it would make it everything except what's in the intersect, I don't know. Some of the problems are like written so weird, but then you're like, alright, it makes sense. Then seeing this, it's like, I guess that would be a different way of writing it.
All right. This one's a neat one, and let me see if I don't know if this is going to take this too far, give you too much, but let me see. Can you guys think if I say, oh shit, maybe unfreeze this. There we go. All right, if I have A, B, where is A and B?
A little different.
Yeah, the little middle part. So where's everything that's not in A and B? Where's everything that's not in A and B? Yeah, so it'd be like everything that is not here, right? Okay. And if you think about it, what does this mean? That is everything that is not in A or not in B. So they give you, and I love you guys, you're all like, what the shit, but they give you a very specific concrete example to kind of work on, but you can actually think of this without any concrete example. Why would it make sense that these would be equivalent? Right? What does the result have? It has everything that's not in A or not in B. That actually represents the same area of the picture. So it kind of makes sense. If you give me a concrete example, it's got to work. And it's kind of nice. You can kind of see it work out. But you can think of this at a higher level, like just a conceptual level.
Yeah.
Like some of you guys are looking at me like, no. But okay, maybe.
It is kind of mind blowing, honestly. That's why.
Yeah.
Like, oh man, I guess. Like with the, I don't remember who made the example. It was like -1. Right?
Oh yeah.
Man, dude, like.
Yeah. See, that's what I love, and that kind of thing happens. And like I think I told you guys, I'll steal stuff from students. They'll do things I never thought of. I'm like, oh good, I'm going to steal that. I'm going to talk about it next time. So a lot of this stuff, especially factoring and stuff, I've stolen methods I've seen students using. That's not to say I had nothing. When the first day I started teaching, like, I know nothing, do some shit, let me look at you.
Yeah.
Anyway, so that's a good thing for you to do too. All right. Okay, anything else before we do what we're going to do today? For some reason, we're going to talk about Chipotle today. We're going to talk about pancakes and blueberries, like I said. All right. Anything else before we get into that? All right. Okay. I didn't mean to bum you out. Yeah, I'm going to be fine. So it's fine. Okay. All right. So, what is really, really cool? Well, before I can get to the really, really cool stuff, and that's not necessarily saying this is not in its own way cool, but this is certainly the less intriguing part of this. If I can find my little notes. If I can't, that's all right. I'll make it up. Oh yeah, there we go. So, we're done with section 2.1. We finished section 2.1. Section 2.2 is building up to the different ways of numeration. So, we talked a little bit about, we have the Hindu-Arabic system, right? So we stole our symbols, we kind of used the symbols that were developed in a certain region of the world, and we just said, yeah, we're going to use those, right? So it's Hindu-Arabic. But what's really neat is that as a civilization, it makes sense you have to come up with a way to represent the idea of how many things there are. You have to be able to write that down, you have to be able to talk about it with somebody else. And if these civilizations have no communication with each other, they could develop vastly different ways to represent the idea of 2, for example, right? Or the idea of 10, or the idea of whatever. Okay, so this gets really interesting. So before we get into that, there's a couple little things we got to talk about. So I think I already said this. You have the idea of number, which if I put like, if I put all this up here, all right. So all of those capture the idea of what? Each of those sets captures the idea of what?
Numbers? Or
very specifically.
3?
What do they all have in common? They all have 3 elements, right? Okay. So they all capture the idea of 3. These could have been 1, 2, 3 for us. These could have meant 1, 2, 3. If you really think about it, they're not any freakier than this symbol, that symbol, and that. These are freaky ass symbols. They are. They just are freaky symbols we're used to. All right, so we have an idea of a number. And then we have the numerals that we choose to represent those numbers. Okay, so I kind of said this before. This seems kind of trivial, or it seems like, whatever, but this is huge. This was a huge development for the human, for us, for our development, right? So one way to use numbers, one very basic way to use numbers is to count things in sets. That's basically what I was doing here. So when we use numbers to count things, we call them cardinal numbers. I like it. Another place we could use numbers, there's like three main ones, and you could probably think of some other little stuff, but there's three main ones. One is to just count things, and that's the one that kind of came naturally, the most natural. You want to know how many cows are over there or whatever, right? The second thing is to identify where you are, like identify position. Like I'm third in line, or that's the fifth one I saw, or something like that. Okay, you're still using numbers, still using numerals, but for a slightly different purpose. And this one we call, let's see, why does this name make sense? Ordinal numbers. What's kind of the root word of ordinal?
Order.
Order. So this is all about somehow this thing is in order, and I can see what position something's in.
Yeah.
I like it. So like you go to a deli, or you go to the DMV, right? Okay. And then the last one is what everybody feared was going to happen to us is we weren't going to have names. We were just going to have numbers, like social security number or jersey number, like a number on your jersey, football jersey, whatever. Those are called identification numbers. And those are the weirdest ones, because do they represent a count of something necessarily? No, they don't. Does your jersey number you wear represent a count of something? No. One semester I was teaching statistics, and I said there were 3 girls that were on the women's basketball team, and I said if you add Michelle's number to Josie's number, you don't get, and they're like, we get Christine, because it was 14 and 2 and she was 16. I'm like, shit. But in general, they don't mean.
Normally it wouldn't.
Normally not, but I was like, of course. So these are called identification numbers, believe it or not.
It's like you can't subtract someone's license number with like.
Yeah, if
someone
you
else's license
did,
number.
you could subtract 2 zip codes, for example.
Yeah.
Would the answer mean anything? What? No. You could subtract 2 social security numbers, right? Would the answer mean anything? No. Right? I'm higher than you.
Maybe if you paired with the zip codes and the social security,
Yeah.
you know, come up with something.
Oh yeah, there you go. Yeah.
Some Jim Carrey.
And it's the number of the universe or
Yeah.
something. It's just, oh geez. Oh no, don't give me the 23.
Yeah. I was gonna say.
No Jim Carrey. Of course Jim Carrey. 23 freaking about. If you have no idea what we're talking about, there's a movie called 23, isn't it?
Yeah,
Just
number
23?
23.
There's no movies that are prerequisites for this class, but I do reference movies every now and again, and I appreciate that reference.
But if you fall down a rabbit hole, ask for help.
Yes.
Start finding the 23.
Before you've fallen all the way down. So when I tell you kids and numbers, what's the first thing that comes to mind, like their first interaction with numbers? What's their first interaction with numbers?
Family?
What do you see them? Learning about numbers, right? Because with family, it could be almost anything. But in the educational system, what are kids doing when they first do anything with numbers? All right, but that's way after they know what 1 and 2 and 3 mean. I'm talking about when they very first do anything with numbers. What do they have to learn? What do they do with letters? What's the first thing we learn about letters? Our freaking ABCs, yes? Don't we have a little song?
Yeah.
Twinkle, twinkle. I mean, ABC, right? Okay. So what's the first thing we do with numbers? We teach them how to say them in order, right? So it's the book calls it Chanting, which is a really creepy image. I'm sorry, for me it is. Anyway, a bunch of kids just 1, 2, 3. I'm like, I'm leaving. I don't know what's happening. So there's an idea of a chant. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean, that's a chant, right? very boring chant, but it's a chant. So you can teach them the order. So if I teach somebody to say A, B, C, D, E, F, G, does that connect anything about how those are used, how those are pronounced, any of that? No, right? But it is sort of the first level. You need to know all the pieces we could do something with. And then we'll start doing something. So with numbers, 1, 2, 3, 4, 5, they can say it, and now we got to go back and say, what does 1 mean? What does 2 mean? What does 3? All that kind of stuff. Okay. I like it. So a chant is kind of like the first level of stuff. Let me say this. Yeah. Let me see. Is this a good place to put that? Yeah. Okay. So this is they start to kind of learn the words and maybe even the symbols, but they haven't connected. Still need to connect the symbol and the word to the idea. Okay, I like it. Does that kind of make sense? So I can see the symbol, I can draw the symbol, I can say that word that represents that symbol. Does that mean I really understand what that is? No. Right? I can teach you here. That's the Greek. Well, let me see. What's a better Greek letter, Jeff? Sure. Does anyone know what that Greek letter is?
Sigma.
Sigma. I love it. Which is roughly equivalent to what letter in English?
S.
S. I love it. So I can tell you. Well, anyway, now it's all given away. But I could put up here something, and I could tell you what it is. It doesn't tell you what it is in relation to anything. It doesn't tell you what does it sound like. Does it sound like I don't know. Or you don't know yet. So still need to connect the symbol and the word to the idea. Before I go there. So one way you kind of start doing that is we use this this notation. So if I have a set A given, let me give us an example. So this here, this notation, if set A is A, B, C, this notation means the number of things that are in set A. That's all it means. It's kind of nice. So how many things are in set A?
3.
Okay, I like it. Okay, so the little n in front of that is exactly what you'd hope it would be. It's just the number of elements in that set. I like it. So there's a video I was thinking about showing, but do you remember? Yeah, we saw last time the cups and the straws. Remember the cups and the straws? So there's a set of cups on the table. And the student was far enough along that they could equate the set of cups to the set of numbers. And I think that's what I pointed out at that point. And that's kind of like what this is doing. There was a set of cups on the table, and the number of elements in that set needed to be understood so they can equate the straws to it. And I know, it's kind of like, this guy's talking about putting straws in cups and freaking making it sound terrible. But there's a lot of stuff behind what students need to connect so they can just use numbers correctly. It's crazy. Okay. Let me see. Blah, blah, blah. Oh, so let me put those two ideas together. So this is an example, but in general. Oh, by the way, before I go too far, this is equivalent to, remember this symbol, equivalent to the set 1, 2, 3, which kind of enforces this, right?
Yeah.
So it kind of makes sense. In general, the number of things in a set is something, oh shit, right? M is some number, 0, 1, 2, 3, whatever. If set A is equivalent to 1, 2, 3, up to M. So obviously, if I had a set that had 8 elements in it, it would be equivalent to the set 1, 2, 3, 4, 5, 6, 7, 8. And therefore, the number of things in that would be 8. Okay. So again, very basic ideas. We're learning some notation to describe those ideas. Oh, cool. All right. So we've already sort of filtered over, so you can see the connection. To go from chant to some higher level thing, we've had to introduce the idea of sets. And one thing you can start to do with sets, so a set that could represent 2 might be something like this, and a set that could represent 5 might be something like, see if I can be any creative at all. Sure. All right. With this picture, can a child understand which set represents a larger number of things? Of course, right? But again, you gotta remember, the kids they've never worked with this shit before, right? They're not gonna say, I've never worked with this shit before. But you can see that this relates to 2 elements, and there's more elements in that other set. So this is a very fundamental way to start thinking of how to order the numbers. Why the order the way it is in the chant that we say, right? So this is a very nice, quick, if you give them 2 bags and it's full of cookies, and you're like, which bag would you want if you could only have 1 bag to take home, and 1 bag had 2 cookies and the other had 5, they're gonna be like, I want the 5 cookies, right? And make sure they're not like something they don't like, right? What are those? I don't like this. So, and then you can say why, because then I have more cookies. Oh, so then this represents 5, this represents 2, so then 5 is bigger than 2. Which of course is groundbreaking, but not for us, but for them it would be groundbreaking.
Yeah.
Okay, I like it. Anything else with the sets to the boot?
Even if they weren't privy to the chant or the concept of numbers, it would probably be like a visual thing. It'd probably be like a visual thing. They'd be like, well, that's obviously more cookies, like whatever.
Yeah.
But
So it's connecting the idea of more cookies to a count of those cookies to the idea of the numerals and how they compare, right? Which is weird. I really want to understand. This is really weird for us, but there's so many levels of understanding and connection that need to happen when we are very young, right? And like we were saying earlier, you're probably going to start teaching like 7th grade or something, but you never know. You might get some of those younger grades eventually, and then you can kind of see how much connection they have to make. What else do I want to say here? Oh yeah. Let me see if this is cool. So watch this. What's the number of things in let's call this set C and set D. What's the number of things in set C? 2, good job. And the number of things in set D is 5. Of course, there's down there, Jeff, so nobody wanted to say it because it's right there. Let me see, how do I put this in together? I can do that. Okay, so that's that. So here's the interesting, we can say that the number of things in A is less than the number of things in B if A is equivalent to, oh shit. Oh, you're all like, how do you take 2 is less than 5? Do you want? So we can say the number of things in A is less than the number of things in B is if A is equivalent to a proper subset of B. What the shit? All right.
So this is C and D, right?
Say again, sir?
You named them C and D.
Oh, is that what everybody's looking at me for? I'm writing this in general, but let me go ahead and make this C and D. Sure. So we can say that the number of things in C is less than the number of things in D if C is equivalent to a proper subset of D. I just feel you guys like, what? All right. Is set C equivalent to a subset of set D? What does equivalent to mean again?
Same number.
Same number of things, yeah. So is set C equivalent to a subset, a true subset, meaning not equal to it? Is set C equivalent to a subset of set D? Yes. In fact, I drew them earlier, the connection, right? Since that's true, then we can say the number that this represents is less than the number that this represents. Okay. So it's different terminology, it's different symbols, but it's a very basic idea, I know. Okay. Now, obviously, this is not the lesson you would throw on the board if you had a bunch of 6-year-olds, 5-year-olds, whatever, right? You're not going to throw this lesson, but this is what's in your head as you're constructing ways for them to learn this stuff out. Okay. And a lot of the, like the Common Core and a lot of the stuff that you're going to have to go by is going to say things in this way. It's a way to talk about these issues in a common language, right? So we got chant that kind of then leads to sets, which allow us to talk about ordering numbers. And of course, what's the ultimate visual for ordering numbers? And this, I don't know, it's a very open question, but if you had to graph all the numbers that are bigger than 5, what would you draw first? Number line, I love it. So the third level is what we're going to call the whole number line. By the way, the very early part of this class, we're dealing with just whole numbers. Right? In fact, just whole numbers. Eventually we're going to bring negative numbers in. And eventually we're going to bring fractions in, which everybody's like, yay. And then decimals, we're going to bring those in. But we're going to start with just talking about whole numbers because that's the way we start with kids, little ones. So of course, 0, whatever, right? So in this case, once you get up to this visual, how can you show somebody that 3 is less than 7? How would you see that on the number line? Why would the number line represent that 3 is less than 7?
Because it's closer to 0, or,
Be careful about that.
No.
I'll tell you in a minute. Be careful about that. I like what you're doing visually there, because 3 is to the left of 7. 3 is to the left of 7. Once we bring in negatives, because negative 1 is closer to 0 than 6 is, right? All right, I got you. Or the other way around. Okay, maybe. All right, and again, we all know this. But it's kind of neat because you can't expect to slap down a number line too early in a child's progression through understanding. There are certain things they have to grasp before you can do that.
Right.
Blah, 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 blah. Oh, good. All right. Sorry. It's funny. This is interesting, but I think you'll agree with me, it's not the most interesting thing in the world. Right? Okay. But it's good to know. You got to know this stuff. You got to take into account what they're not going to come in understanding that we're like, it's just a number. Now, I'm going to erase this part. All right, I'm going to erase this here. So I'm going to draw something on the board. I think most of you will understand it. I would think. Check. Do you understand it, Jeff? All right. What does that represent? Tally marks. I love it. That's what they are. What do they represent? 18. Kick-ass, right? And why are tally marks a very basic, quick way we do things? Why was it so quick to see that was 18? Would it be if I did this?
So sets of 5.
Good. So it groups them in sets of 5, right? Visually very easy to distinguish. That one at the end just kind of falls over. Ah, shit! And everybody else catches them. Whatever you think on it, right? And it makes it very quick. Okay, that's amazing, right? Ooh, tally marks. Well, what's interesting is there are civilizations where I can't remember which civilization. There's a stick.
The Incas.
Yeah, is that the one with a stick with certain markings on it?
And the string.
They tie the strings on. Yeah. I like it. And it's kind of related to this, but not directly, but it's a nice visual kind of a quick way to identify certain numbers.
Very friendly.
Yes. What was the other one I wanted to do? Can't remember now. Oh, that's right, okay. So obviously this has flaws, obviously. Would you want to use the tally method to represent the number 9,947,219?
Maybe in jail.
Huh?
Maybe in jail.
Exactly, that's where you normally see those, is somebody's jail cell. I like it. So we needed to develop a way to represent larger numbers easily. And there's a really, all right. Egyptian numeration system. All right. I have a few of these memorized, but not all of them. So here's what the Egyptians decided to do. They decided that this is sure enough 1. That's a staff or a rod, right? That's 1. And then they decided this is 10. And that officially is a heel bone, believe it or not. So they're run across enough of those that everybody knows what that means. You can do it, Jeff. You know what this is. Is it a scroll? I think it is. I'm going to put it down there. I'm going to see. That was a bad way to do it, Jeff. Scroll, yes, is 100. And then I think, let me make sure, because I don't have to draw this twice. A little flower is a lotus flower is 1,000. Now I'm going to need, oh yeah, this is my least favorite one, is because I can never make it look like anything except a banana or something. It's supposed to be a pointing finger. Oh, screw it, just now it looks like a bird. I don't know. I'm just going to draw a banana. So it's a pointing finger is 10,000. I always forget. All right, I know the million is my favorite, and then oh yeah, of course, Jeff. Come on. Little fishy dude. Little fish dude is 100,000, and then an astonished person is 1,000,000. I love that. Like you won $1 million. Oh my God.
Cool.
So it was really cool when I first learned these, and then I went to a museum with some Egyptian kind of glyphs that they found on the side of whatever, took out of pyramids, whatever, and you start to see something recognizable. It's just so neat. Now, how the shit does this work? This is, all right, how is this different from our system? How does our system work? I should have started with this. How does our system work? What does that really mean?
200.
So I've written one number up there, right? So that means 200. How did you know it meant 200?
So the position? The position?
Yes, it's because where it is in the number itself, correct? And that is remarkably good. And that's why we still use it to this day. It's a very nice way to do things. Egyptians did not have a place value system, or a positional value system, right? What they did was this. This is kind of cool. If they wanted to write the number 74, they would put 7 heel bones and then 4 rods. And they didn't have to be in a straight line. They could just be all over. And normally, on some of the tablets, most of them, they would have like little regions that were well defined, and they could put whatever symbols anyway, they would represent one number. So as long as it was well defined, what the boundaries were, you could put the symbols however you want to. So you could be kind of creative in how you position those numbers. Okay. So how would you write the number? Well, what's really nice about this is, how do I write 2 million in Hindu Arabic? Well, I got to put 2. Okay, now I'm done. How do I write 2 million in Egyptian?
2 lottery winnings.
Yeah, so in Egyptian, it would just be, oh my God, this guy's head got blown. Oh, sorry. Okay. 2 astonished people would be 2 million. That's awesome. Can anybody give me a number that really sucks in Egyptian?
the 90s, 900s, and
Yeah, like 9,900,000, 9,900,000, 999,999. You would need 9 of all of these, right? As I slowly die, hold on. Okay, but fundamentally, Egyptian is crazy simple. I'm not going to make you memorize the symbols, by the way. Right? I'd never make you memorize something I don't have fully memorized. But the actual construction of numbers is simple, but that does lead to problems. I don't want to use 9 of all of them. Holy crap. Okay, I like it. So Egyptians are pretty straightforward. They use what we call an additive system. Does it make sense why we call it additive?
because they just
Yeah, because if I put 2 astonished people, I add 1,000,000 to 1,000,000, get 2,000,000. So it's inherently additive. Our number system is based on 10, right? Each position is another power of 10. Isn't the Egyptians basically based on 10 also, in their own way? Right? Because they're all freaking multiples of 10. And that's that commonality of humans have 10 fingers, so that's a good, and this is the way we normally kind of start counting stuff, is with ourselves. There's actually a civilization, I think it's Papua New Guinea, where the names of the numbers correspond to. So they start at the toes and they count up one side, and then they count down the other side of their body. So they look at us and they're like, that's cute. There's so many things that you could use. I'm like, oh shit, these joints and stuff, it's crazy. So this is an additive system. Now, let me do one more, and then I've got okay, it'll work out. Should I give this to you? No, I'll give it to you. Now the next, has anybody here ever done an outline for an English paper? What do you normally use for an outline to distinguish the pieces? Roman numerals, I like it. So all of us, and you've seen clocks that have Roman numerals. Why do you think some clocks have Roman numerals? To make them look neat? No. There's actually a really good reason, because they're easier to distinguish from far away, those symbols, right? What else uses, or at least did? They would advertise something coming up, and there would be a graphic of the numbers in like stone, and they would fall. They're like, yeah, this Sunday, Super Bowl, right?
Yeah.
Super Bowl 49, whatever. It had all these Roman numerals, and they're all stone, and they'd all drop. Super Bowl 50 in Roman numerals is L, and that's it. It'd be Super Bowl L. It's like, oh shit. Anyway, sorry. Also, anybody ever watch the movie all the way to the end?
I have the year it was made.
You see MCM, blah, 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 normally?
Yeah.
Yes. Okay,
Well,
so.
you don't see MCM anymore.
Not anymore, yeah, exactly. MCM is for like, what I'm used. Back when they knew how to make movies.
Isn't there a thing where clocks, there was like a clockmaker and he wrote the 4 wrong and then he got killed?
Yes.
Yeah.
Well, okay.
I remember the name, but
I can't
because
remember.
now you see clocks, it'll have the 4, not the IV. It'll be like the 4 bars.
Yes.
So they do that in honor of.
I love it. That's a perfect story, because that leads into one of the weirder requirements for Roman numerals to work. So let's just set this up. So everybody knows this is, so for Roman numerals, there we go. One is 1, yay. All right, so the I is 1. And there's a reason you actually don't write it like this, and we'll get into it. What's the next number up from 1? 2. It's crazy. So how do you? So the next real new symbol is V, but V is 5. How would you represent 2?
2 bars.
Boom, boom. How would you represent 3? Boom, boom, boom. And this is what you were just talking about. You never have to or are allowed to, right? You don't need to, and you're not allowed to use a same symbol for more than 3 times in a row. So you can't represent 4 as bum, 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 bum. We know how to represent 4, and we can kind of, what do you call it, back engineer what the rules are, or at least one of them. Somebody else tell me, how do you write 4 in Roman numerals?
Isn't it 1B?
Good. I love it. And of course, what's 6? VI. I like it. So this is 1, this is 5, so and this is 5 and this is 1. So why do they come out to be different numbers? Does anyone know? Right? I and V, that's 1 and 5. So why is it 4 here and it's 6 there? So what's it seem like the rule might be?
You're like subtracting and adding.
Yeah, so when do I subtract? When does it look like I subtract? When the first dude is
In front of.
yeah, so you gotta be careful because there's something in front of something else here too, right?
The lesser value to the left.
When the smaller one is in front of the bigger one, subtract those. Anything else you add. So Romans are still basically additive. They just implemented something in there that helps them out in some cases, like related to Egyptians, for example. Right? And then of course you got 7, J. You can do it, buddy. Hey, how do you do 9?
So
IX, I love it. Which again, so what does X represent?
10.
10. So I in front of X, smaller in front of bigger, subtract. This is really 10 minus 1, 9. Okay, I like it. So let's just introduce the other symbols by themselves, and I'm going to hand this thing out. The next symbol up from 10 is 50, and I kind of gave that away earlier. That's L. Does anyone know what it might be for 100? And then we can talk about why it makes sense. Kind of gave it away there too. Didn't need to. Yeah, there's 100 what's in $1? Cents. Yeah, okay, I like it. And then the next one up from there is going to be 500. Yep. And then sort of the last one is M for 1,000. I like it. So how would you write 3,000?
3 F's.
Yeah, M, right? So here's the last piece I haven't told you about, and then we got to talk more about the rules. So we already know that smaller in front of bigger means subtract. There's a little more to it. I already know I can't do the same symbol more than 3 times in a row. So how would I write 4,000? We don't know. I haven't told you enough yet, so it's a little evil of me, but too bad. So what they have, this is kind of unfortunate, but oh well. They used something that means something else for us, but they used, that's 4, correct?
Mm-hmm.
That's 4,000. So anything with a line over it. So civilizations all across the way, they love the line over things for various reasons. This is what the Romans used it for, right? And that's why I said earlier, you see this, I'm going to read that as 1,000, because that's going to be 1 with a line over it. Okay, I lock it.
Did they use the line underneath, or no?
Not that I know of.
Okay.
Yeah. Okay, so let me give you this. This might be easier than me making some more stuff up here. So this is kind of like a summary on the first side where it says Egyptian and Roman. Summary of what we just talked about. So, in case you want something to reference, let me see, do I need to put it over here? No. So what I try to do is the Egyptians are up there. That's nice. And in the back, you can see I took out from another book. For Math 120, I would teach these numeration systems. So I kind of stole this from that book on the other side. And at the bottom, you'll see a lot of symbols, some of which we haven't talked about yet. So on the front, you've got Egyptians, I got Romans, and there's 3 rules, basically, for Romans. First rule we talked about, but there's one little thing that we haven't talked about yet. So with subtraction, if I wanted to write 99, what way do you wish it would be allowed?
100 minus 1.
100 minus 1, yeah. But the way I just said it tells you no, right? And there's actually certain situations where that could be misleading. So they made a rule where like 1 can only be subtracted from the next 2 higher things.
Mm-hmm.
So it could be next 2 higher main things. So 1 can be subtracted from 5, 1 can be subtracted from 10. I like it, right? So if I wanted to write 99, how would I do it then?
Have to do 10 minus 100.
Yeah, okay, now we got it. So the way you can start to think about this is you could do that 99 is 90 plus 9. 90 is 100 minus 10. Are you guys semi with me? So again, let me restate this, and it's on that paper, thank God, so you have it written down for yourself. But the rule is, subtraction is kind of nice. It's always just pairs. It's only pairs of things, right? So I can't do, for example, this is not how you do 8, yes? You can't subtract more than one thing from somebody else. So it's always got to be a pair of things that you're doing it with. But also, 1 can only be subtracted from 5 and 10, right? 10 can be subtracted from 50 and 100. Do you see what I'm saying? So it's just the way they set it up, and if you don't like it, you got to create a time machine, go back, learn, Latin, so you can talk to them and convince them not to do that, right? Until it happens, let's see. If anybody was going to make a time machine, it would have happened already. All right.
It already did.
So 90 is 100 minus 10, and then I got to do plus 9. We basically know. We don't have to do that. We know what 9 is. So 100 minus 10, how would I represent 100 minus 10? What's got to come first to represent subtraction? The smaller one. So what's 10? X. And what's 100? C. That's 90. And then what's 9? You know what 9 is? IX. That is how you would write 99. And it's their rules. They get to set up their rules. I like it. Let me see. Was there anything else? Add any other letters sitting next to each other. So what you always want to do when I give you a string of these numerals, you locate the pairs where it's smaller in front of bigger. Those are the first things you do. And then you just have to add everything once you subtract those. Okay, I like it. So, I want you to try. Yes, go ahead.
Question. So
Yeah.
would that mean that 50 can be subtracted from 500?
Oh, can 50 be subtracted from 500?
Yeah. If I wrote LD, would that be 450?
So if you wanted to write 450, now think about it. So this would be, so the quick answer is no.
Okay.
Because again, you'll notice it's factors of 100 that I can subtract from other things.
Okay.
That's another, I guess that's another layer that I just kind of take for granted, but that's a good point. So it's all the factors of 100 that I can subtract from other things. So how would I do 450? How would I do, so it's 400 plus 50.
So you would do CDL.
Yeah, 500 minus 100
Uh-huh.
plus 50.
Got it.
Yeah, so it'll be C from D plus L.
Got it.
I like it. Okay. So on this side with all the problems, right? And again, at the bottom is a quick reference. Don't worry about the stuff that doesn't look familiar at all. Just worry about Egyptians and Romans right now. I want you to try to do 2, 4, well basically I want you to try to do 2 through, where to end up here? Yeah, 2 through 16 even. Try to give those a shot. I'm going to let you work alone first, and I'm going to let you get together and compare answers in a minute.
It's not in the key, but what was the finger, the wagging finger?